In question 4a, we're to use the equation W is equal to VQ to show that the volt may be written in base units as kilogram metre squared, amp to the -1, seconds to the -3. Well, if we rearrange for volts is W over Q, or voltage is W over Q. In units, work is Newton meters, from work done is force times distance, and charge is in coulombs. The Newton from F equals ma is the force that would give 1 kilogram an acceleration of 1 meter per second squared, multiplied then by the meters and divided by coulombs, which in base units is amp seconds. We can then simplify to kilogram meter squared amp to the -1 seconds to the -3 as required. In B, we have a circuit, and we're to show that the resistance of the LDR is about 6,800 ohms. Well, they're in a series circuit, and current is potential difference over resistance. The current will be the same through the fixed resistor and the LDR, so you can say that the potential difference across the resistor over the resistance of the resistor will equal the potential difference of the LDR over the resistance of the LDR. Rearranging for the resistance of the LDR, that is then the potential difference of the LDR over the potential difference of the resistor multiplied by the resistance of the resistor. This is then the 5.1 volts that we're told is across the LDR over the 0.9 volts, which is what's remaining of the 6 volts, which is across the fixed resistor, times the resistance of the fixed resistor, which is 1.2 times 10 to the 3 ohms, and this does come out at 6,800 ohms as required. In part 2, we're to calculate the current in the circuit. This is potential difference over resistance. The potential difference is 6 volts. The resistance 6,800 for the LDR plus 1,200 for the fixed resistor gives a current of 7.5 times 10 to the -4 amps, or 0.75 milliamps. In C, we're told the circuit is moved so that the LDR is now in sunlight, and we're to describe and explain how the readings on the ammeter and the voltmeter will change. Well, the ammeter reading will rise, the voltmeter reading will fall. The reason being the resistance of the light-dependent resistor reduces in the light, therefore the overall resistance of the circuit will have fallen and more current will flow. If there's a bigger current through the fixed resistor, it must have a bigger potential difference across it. The potential difference of the supply is fixed, so therefore the PD across the light-dependent resistor must have fallen.